Hello everybody and welcome to a session on Engg graphics with me Yash Chawla from Parul Institute of Engineering and Technology. Last time when we met we were solving GTU question paper of this 2011, which is this one winter 2012 winter 2013, that is. So that is the first semester of the academic year 2012 and 2013. So let's get on with it and solve the rest of the problems that were left over in the question paper. So we'll begin with question number. So this is the first semester winter 2012 that we are solving. The date was 23rd of Jan 2013. Okay, so the first question that we are going to solve today is question number 5b of the question paper. That is, a square pyramid of side length of base is 30 mm and length of slant edge 80 mm is resting on HP such that all sides of the base are equally inclined to VP. Draw development of surface of pyramid. Now what we have to do is basically we are given a square pyramid and we need to first of all draw the base, that how it is looking. It is lying on HP, and we have to then draw the development of surfaces. Now for those of you who have not understood the development of surfaces, so what we are going to do is, so what is basically development of surface? That is the question here. So say if this is a cone, I'm taking a cone in this way. What happens is that this is a cone that I have. Now if I said you should develop the surface, then I'll just unwrap the cone. So I will have the surface with which the cone was made. So another example of this is a cylinder. This is a whole cylinder. Now if I'm said to make the surface that makes this cylinder, then we just unwrap the cylinder in this way and we have a rectangle that shows that yes, this cylinder is made out of a rectangle. Okay, so for that we'll move on to the teletop and we'll start off. We'll start off with the solution of the problem. So first of all, we'll draw the the initial condition in which the pyramid is lying, and thereafter move on to drawing the structure, that is the development of surface. For that, the first thing that you should do is you should clear your scale as I've done, because it makes dirtiness on the paper. Now first of all, draw a line XY, and then we know that the cone, it is written in the question that a square pyramid of side length is resting on HP such that all sides are equally slant. So we know that top view here below line XY, here we'll have the top view and here we'll have the front view. Okay, so for getting the base of the pyramid, first of all, which is a square, what we need to do is we first of all need to draw a straight line. Thereafter, at any point we'll do this, a line parallel to line XY. Now all the sides are equally slanted. That means the corner of the square will lie here. Then these four lines will contain the corners of this pyramid, that is the base. Now what we'll do is I'll just draw the base, that is the length is 30 mm. So I'll just draw the base at 30 mm, where first of all I'll draw a line equal to 45 degrees. On both the sides. Okay, and now simple as that, I'll just make the base of 30 mm on that line. And similarly, parallel to that, another 30 mm. And thereof I will just rub it off. This line is, I have to just correct it off. So this is it. Okay, so here we have a whole square of each side as 30 mm. I'll make it dark using a sketch pen so that it's visible to you. Okay, and this is 30 mm. Right, so now I'll mark the points as A, B, C and D. Thereafter I will sketch off the projections upwards. And I'll again mark them as A dash, B dash and D dash. Both the points will lie here, and this is C dash. Also I will mark the center, which will lie somewhere here. I'll mark the center point as O, that is the top of the pyramid, and I need to connect these. Because it is a pyramid, these all sides will be connected, right? And now 80 mm is the slant edge that is given to me, so of the pyramid. So 80 mm I'll take on my compass. Putting my point at C, I'll first cut an arc here. Thereafter again I will cut an arc this way. So then join this. Just draw the arc again. So it comes somewhere here. This way. So this is the pyramid, and then I will just join it. And name this as O dash. So this is the pyramid for which I need to draw the development of I need to develop the surface of the pyramid. So for that, what I need to do is a line which is parallel to O dash and C dash exactly has to be drawn here, as I'll draw, and the length also has to be the same. So what I'll do is I'll just draw a line which is exactly parallel to this line this way. This line is exactly parallel to this O dash C dash and equal to O dash C dash, and I will name this as the center as O. This is O and this is point A. Now what I need to do is again the same radius, putting it at the center, the radius equal to same. I'll draw an curve. I'll draw a simple curve. Now after doing this, what I need to do is I need to find out what sides are there. So this is one of the edges that I have already obtained. Now I need to obtain all the other edges which form the development of the So for that, what I need to do is I'll take the distance AB, that is equal to 3 centimeters, and I will cut arcs, successive arcs on this. How many arcs do I need to cut? I need to cut 4 arcs. Why 4 arcs? Because a pyramid has four surfaces. So I'll need to cut 4 arcs. And now I will join the final arcs. And I will join the rest of the points. and I will join these lines, each of the points. And then I will name them as B, C, D, A, B, C, D, and finally A. Why A? Because these two lines, when meet each other, they form the pyramid. Now when I will just join it, it will be more visible to you. Joining all these lines as well. Okay, so now what has happened here is that this pyramid was this way, so I have just opened all the surfaces, and these lines in between, these lines are known as folding lines. Folding lines. Now if I take this structure that is there, that is O, A, B, C, D, and A again and O, and if I fold them from these lines which are there marked in red, and then I combine A with A, what I will have is this pyramid that is given to me. That is why this is known as development of surfaces, that this is a solid surface that is given to us, and this is the 2D plane, two-dimensional plane with which this surface can be created. So this is the solution of the problem 5b. Now please don't forget that marking the dimensions and labeling them are very, very critical. So I will do that. This is 80. Should use a good ruler and scale to mark the dimensions. Again, this is 80. So dimensions, and this should be perfectly done. So this is the solution of the problem, that is question 5b. Okay, now let's move on to the next problem, that is question 6a. Now in this we have to draw an orthographic projection, that the view is given in the question, and we have to draw the elevation, we have to draw the top view, and we have to draw the left hand side view. And there's one thing missing here in the slide, is that you have to make this orthographic projections in first angle. Now remember what happens in first angle. There are two types of angles in which we can draw the projections. First is the first angle, and second is third angle. Now if I am drawing my first angle, then what happens is, I'll show it on paper. What happens is first angle and third angle. So in first angle I have my front view, then below that I have my top view. On the right hand side I have my left hand side view, and on the left hand side I have my right hand side view. And what happens in the third angle is that top view I have it here, below that I have my front view, on the right hand side I have right hand side view, and on the left hand side I have left hand side view. So the solution varies as the if I am said left hand side or right hand side, so it varies depending upon that. So when I am having a left hand side view in first angle, then it is drawn on the right hand side. That's what will happen in this particular question. I am told to draw left hand side view, so wherever I will be drawing my top or front view, besides that I will draw my on the right hand side I will draw my left hand side view. So let's see what figure is there. Now this is the figure that has been drawn. It's given in the question, and it's always given to you in the question paper, and this is the question, it is 6a. So we'll be solving this question. Now what we need to do is we need to draw the front view. Now this point X that you see here with an arrow, this X, this shows that this is the point from where the front view has to be drawn. Then left hand side view will be drawn from this way, and the top view will be drawn from here. So we will begin by drawing the front view of the question, and let's start by drawing it. We'll keep the figure and we will start drawing. Okay, let's start. First of all, we'll start from the extreme left hand corner, and we will have, see, we have a straight line. What are we going to see in the front view? We'll have a line of 25 mm. Then we have this which is given as 6 mm in the question paper, which is given as 6 mm, right? And again, then we have a 20 mm straight line, 6 mm vertical line, 25 mm straight line, 7 mm vertical line. Then this length is given to me as 15, which is given here, 15. From there, this again is 5, and then this is 12, then again this is 8, then this slant edge has to be drawn, this is again 5, and similarly the whole structure of the view will be drawn. So we'll draw it. Okay, so let's begin by first of all drawing the front view, that is the elevation. A 2.5 mm straight line will be drawn. 2.5 mm straight line is drawn. Then 6 mm below, that is vertical line. Then I am given 20, so it is 20 mm. Again 6 mm vertical line. Then again 25 mm. Okay, then I am given 7 mm vertical lines on both the slots, so I will take 7 mm vertical lines on both the ends. Okay, now next is 15 mm from both the sides. Parallel first of all on this side I'll take, then 15 mm this side I'll take,